Hello everyone and welcome back to another interesting video on African Tech Gurus. Today we are going to start the very first video in the series on creating your own shell environment, your own simple shell, and we will start by breaking down what are the different system calls and the different functions that we have, understand their prototypes, and figure out how to use them in creating our own simple shell. So we will take this step by step. And please make sure you have subscribed so that we learn together. If you're new, please do subscribe. If you know someone else who's learning how to create their own shell as well, also let them know that there's a place called African Tech Gurus where we can learn technology by actually doing and understanding each and every single bit. So the very first function or system call that we will be looking at is the write system call. In this case, we are going to use write because we have been restricted to use write, or we are deciding to restrict ourselves to use write so that we are able to understand it deeper instead of using printf, which can do the same thing. So before you start, it is important to note that the system call write is a very low level system call. So it will just help us to write whatever data that we have directly to either the file that we are writing to the file or to the specific file descriptor. And we look at this as well, what these things are. And since it is a low level system call, it will do so without formatting the data that is being passed to the file or to the file descriptor. So it being low level and it not performing any formatting to the data, it also does not append a null terminator to the string at the very end, and it also does not add line breaks automatically or a new line to the end. So it will just take it as it is, whatever data it is that you have, and either take it to the file descriptor or to a specific file that you're writing to. So it will just simply transfer the specific data that you have in bytes. So it will take the number of bytes of the data that you have used from the buffer, and we will look at this later, from the buffer to a file or to a file descriptor. Another thing that you need to note is that the write system call is also a blocking call. So what this means is that it waits until all the requested data that is needed has been written without any errors. So if you're building a program, you also need to take in error handling as well. So that is part of some of the aspects or some of the requirements that we need to meet when we are creating our own shell. So let's jump into it. The very first thing I want us to do is understand what is this write system call, what is its prototype, and what are the arguments that will go into the prototype. So the write system call, this is its prototype. Line 44 is its prototype. So what it will do is we'll just use it to write data that we have from a buffer to a file. So it can be an open file that we have opened, and we have specifically opened that file in write mode such that we're able to write into it, or a file descriptor. So there are three file descriptors. There is the standard output, there's a standard input, and there's a standard error. So in this case, we will either be writing to the standard output if it is the correct format, or if there's an error, it should go to the standard error, which is a specific file descriptor. So we will find this write system call in a library called unistd.h, and this library or header file will contain the functions or the body of the function to the write system call. So let's just call this header file. So the next thing that we see from our line 44, which is our prototype over here, is we have the s size underscore t. So what does it do? So what it simply does is it just tells us that we're going to use this write system call, and the data type that we're going to get from this is assigned size of bytes. So remember what I've said is the write system call, it will write or transfer this data that we have from the user or from input from a buffer, and it will take it to a file or a file descriptor, and it will do this uh, depending on the number or the specific number of bytes that we have. So it just takes the specific number of bytes that is there in the buffer to a file or to a file descriptor. So that's why it's important for us to use this, because if we do get an error, -1 is the value which has been assigned for errors, and -1, it has the negative sign, so that means it's how will I say it? It's signed. Yes. So we need to specify here that it is signed. So the next thing that we do see is the write system call. So that's what you write, and we use parentheses, and it will take in 3 arguments. The 3 arguments, we do have the very first one, which is the file descriptor, and its type is an integer. So here the file descriptor, it just indicates where to write the data to. So there are 2 places generally that you can write to. You can either write from an open system call, or another system call, or a predefined file descriptor. And in our case, we are going to use the standard out underscore file, which is the standard output, and the standard error if we do get an error. So it can either be we are writing to a file that we've opened in the write mode, or we just want to display it to the standard output. If everything is okay, if we get the correct output that we want to write, or to the standard error if we do get an error. The next argument that it takes is it takes a buffer, this one. So it takes a buffer, and in this case, this buffer is a pointer. So we use the asterisk sign to indicate that this is a pointer, and it is a pointer to the buffer. And the buffer, what it does is it will just hold or contain the data that we have written. So it will be, think of it like a container that will hold whatever the user has typed, hold it such that we can use it in the next step. And it can be of any type, but here we are using void, and this buffer will always contain a constant. The pointer is a constant, so that's it. And we are using void so that we allow for flexibility to write any kind of data. We don't want to restrict ourselves to only integers, to only strings, or to a specific type of data, so it has to be flexible. The next argument that you're going to have here is you're going to have the count variable or argument, sorry, which is the number of bytes to write to from the buffer. So we have already figured out where we are writing to, wherever we are writing the data to. So in our case, we might say we are writing to the standard output, and we will have an example of this. And we're saying whatever it is that you're going to write to the standard output, the user will write it. It will be contained in a buffer, and this is the buffer over here. So it will be contained in that buffer, and the next argument will be, it will check what is the number of bytes, or how many bytes are there in the buffer. So those are the 3 main things that write needs to kind of know. Where am I writing to? Where is this data contained, which is the buffer, and how big is that data? And that's the only thing you need. So let's jump into an example that we do have over here. So as we have looked at here previously, we do have the uni.std.h, which is the header file that we will get the write system call, and that's the same header file that I have used here in line 2. That's there. For the standard output, it is contained in the stdio, which is a standard input or output header file. So that contains that function. So we need to include our stdio. So the next thing that we are going to use is we need to figure out how big or how many bytes are in the count, or how many bytes or how big is the buffer that we do have. So we use the strlen function, and it is contained in the string.h header file. So that's there. So let's start. So I've already written this so that we save on some time, but I'll just help you see exactly what you need to do. So here we do have the main function, which is where we'll be starting, and we've not specified exactly what we want to get from it. That's why we're using voids, that we have the flexibility that we do want to have. The next thing I'm going to do is I'm going to define a prompt. So here I've defined a prompt called shell prompt, which will be the specific characters that will be the prompts themselves that I want to display to the output. So it will be the pointer, and the pointer will contain the specific characters that are my prompts, and the value or the return type will be the characters. So that's why this is here. We're just defining a string, and a string is a series or an array of characters that will contain our prompt. The next thing that we're now going to do is we've already figured out what the prompt is, whatever character or characters we're going to use as our prompt. So if we remember this, our write function, we need to specify the file descriptor. So where are we writing this data to? We also need to tell the write function where the data is going to be contained, or where it's contained, and how big that data is. So here we've used our write function. This one, it's this one. And we say we want to display to the standard output. So that's the first argument that you want to put. The next argument is the buffer that contains or will contain the specific data that you want to display to the user, or we want to display. And here our data, or what we want to display, is these two $signs, which will be our shell prompts, and those two $signs are contained in a buffer or a location called shell prompt. So that is the second argument that you're putting there. The third argument is strlen, and it will count how many bytes are in the buffer that you have passed. And that's how I'll simply start the first step of creating my own shell program. And if everything runs perfectly, it will return 0. So for now, we just want you to understand this concept, not do anything, and let us open our terminal and run it and see what it gives us. So I've already moved to the specific location where my write.c file is. So the next thing I want to do is list the files that I do have, and I do have the write.c. I had actually run it, and it gave me this a.exe, and that just means a is the name of the executable file. And how do I know it's an executable file? Because it has the exe extension at the end. So if I wanted to compile this program, write.c, how do I go about it? I use gcc, and I just write the name of my file, and that is there, and that's successful. The next thing that I do is it will have given me the executable file, and let me run the executable file a.exe. So if I click enter, it should give me the two $signs, which is exactly what I want. It will display the specific prompts that I want. So we have successfully been able to use the write function to display a prompt. And the next thing that now we need to do, which I think we'll do in the next video, is figure out how to always get input from the user, because this prompt, what it's supposed to do is just supposed to alert the user that, okay, now give me the commands or the specific thing that you want me to do. So that is what we will do in the next video. If you've reached to the end of this video, thank you so much for learning with us. We want to become better African tech gurus, and we want to create solutions for our home, which is Africa, and the different countries that we come from. So thank you so much. Share this video with a friend. Make sure you like it. Make sure you subscribe, because it really helps us and it supports the channel, so that we are able to know what kind of content you want, and we are able to deliver that to you. So until next time, happy coding.